Welcome! This video explores writing functions in C++. So functions get us two things. Functions are a tool that allow us to provide abstractions in our code, to think at a higher level, and they allow us to reuse chunks of code, to avoid having to reinvent the wheel, retype the code, or copy it and paste around in our program, and potentially have the same code in multiple places, which then makes it harder to modify or maintain. Our goal is to take something like the logic for how do I raise 10 to the fourth power, and instead of writing the code to do every step, every time that I want to use that recipe, to package it into a function so that I can simply say something like calculate pow, this number to this power, and I get back the answer. Now at some level the code has to exist. There's got to be a for loop or something there somewhere to multiply, in this case 10 by itself 4 times, but we're not confronted with the low-level details of how the function does its job as I write this higher level chunk of code. All right, that's the power of an abstraction. I just say, well, I know there's this pow thing, I call it, it does its job. Now, we've already had experience reading function headers or prototypes. This is what describes the contract between the caller of a function and the function itself. It describes what the function is going to return, what the function's called, what information the function needs to do its job. The only thing that the function header doesn't specify is how the function does its job. And for that, we add a function body to the header. It's a block of code surrounded with curly braces that has one or more statements that actually define how the function that we're declaring does its job. So, for example, here's a function called max. There's a standard library function called max, but if we were going to build our own version of it, this is what it might look like. I can see that the name of the function is max. I can see that it returns an integer to me. I can see that it requires 2 integers to do its job, that those integers are called num1 and num2. And then here is the body that actually does the work. It declares a variable, it compares the 2 numbers that it was given, it sets the result to be the larger of those 2, and then returns that value to us. Given that definition, I can now call the max function from my code by simply saying max. The function requires 2 parameters. Right? It's going to call those values num1 and num2, but the important thing is that they're just 2 integers. So I need to make sure that I pass 2 integers, either actual integer values or variables like I and j that hold integers, and then I know I'm going to get back an integer answer. And so I better store that or do some calculations with the answer, do something else. Now, for that to work, that calling of the function, max, needs to come after we've already declared and defined the function. So in this code, before we get to the main function, we have the max function written. That function ends and is finished off. And at that point, it's now available for use. As the compiler comes through, it'll see this instructions. These are the instructions that tell us how to do max when we need to. We're not going to do anything yet. But then as this code is being built and we see the instruction for, oh, it's time to do max, great, the compiler now knows, oh yeah, that means to jump up here and to run this code. So now let's take a closer look at the ingredients to writing a function. Starting with a function name, the goal of this part is just to identify what the function actually does. Generally, we should favor readability over terseness. If we're using a function all over the place, it may feel convenient to give it a name that's only a couple letters long, so we can type it faster. But ABS is probably not a great example of how to name a function. Until you've written a lot of code using it or gone and researched it, it's not clear that ABS means absolute value. Right? A better name for a function would be absolute value. The name is like any other identifier. It's got to be all one word. It can't start with a number. It can't have odd characters. And generally, we write these in what's called camel case. Camel case is simply where we have a lowercase letter for the first letter, and then to make longer names, we smash together words like get hour of day and just capitalize each additional one. There are other styles. Sometimes you'll see people smash words together with underscores separating them. The particular style you use is not super important other than you're consistent. All of the book examples and my examples use the camel case, and so that's generally what you'll see from me. Next up, the parameter list. That is the extra information the function is going to need to do its job. And there may be one parameter, there may be multiple parameters. Here's a function ABS that has one parameter. All right, earlier we saw the max function that has two parameters, so they're separated by a comma. Each one has a data type and the name of the piece of data that it describes. This is how we get information into a function. If I call the ABS function that we've got declared here and I pass it 10, that means that as this function starts executing, number is going to be set to 10. Number is just a variable that is only going to exist inside this function, and it gets its value from whatever gets passed in to the function. Once the function's been called and the parameters have been initialized with the values that were passed in, that's when the body of the function executes. And in the function body, our job is to write whatever code is necessary to do the job using only the variables that exist as parameters and any extra variables we declare. We can't rely on information from outside the function other than what got passed into it. And eventually we're typically going to return an answer at the end of the function. That returned value needs to match the declared return type. All right, this function declares that it returns an integer. You can only ever return one piece of data from a function in C++. So we're supposed to return an integer. We've made this promise in our contract. Here's where we fulfill that promise. I promise to return an int. At the end of this code, it returns number. Numbers of data type int. That satisfies the contract. It's okay to have more than one return statement. We could write this absolute value function. You can see the existing one has number. If the number is less than 0, it just negates it to make it positive and returns that value. We could write a similar version that says we're taking a number. If it's less than 0, negate it and return it. Otherwise, just return it. That functionally would do the same thing. In really complex functions, it can be hard to track down all the returns if you have returns scattered all over. So sometimes people prefer to have just one return statement at the end of the function, make it really clear where it returns from. But the critical thing is every possible path through the code has to have a return. In this version of ABS that's broken, if the number is less than 0, we negate it, but then we're going to skip the else and we never actually end up returning a value. And I get this warning, control reaches end of non-void function. This is a really dangerous kind of warning because it's unpredictable exactly what we're going to get back from this function. It may look like we get back number. It may look like we get back just random junk. So this is one of those warnings you need to be super careful, kind of paranoid about. If you see this reaches end of non-void function, you know, okay, somehow I'm not returning in my code. And so either at the end of the function I need to return, or I need to make sure that I return in this if statement. If your function has nothing to return, if it just does a job and then is done, we declare it to be a void type. Void means nothing. It means I don't return anything. Here's a function that takes in a double and prints it kind of formatted to look a little bit like money, with a $sign in front and 2 decimal places. That function doesn't give us back an answer, it just does a job for us, prints out something to the console. So that function would be declared as a void function and doesn't need a return statement. If you really want, you can put a return with nothing after it, just return semicolon at the end of your function, but a void function doesn't even need a return statement. Just when it gets to the closed curly brace, it's going to go return back to wherever we called it from. So now for some rules about writing functions that work well and are easy to understand and maintain. First key thing is our communication. We want to communicate with a function using our parameters and return values. We want to send information into a function by passing it in. We want to get our answer back via its returned value. That's normally what a function should do. Take in some information and return it to us. In general, what that means is functions generally should not be using the console, should not be reading in information, and should not be printing out information. If I'm writing a max function, its job is to be called from other code, take numbers we're currently working with, process them, figure out which one's larger, and give that back to me. If the function goes and reads in numbers from the console, it's now ignoring the inputs to the function. And this function, great, it can read in from the console, but that's all it can ever do. I can't use other math I've already done as the inputs to this function. For getting the answer back, I want this function to just give me, if I'm writing a main function, I want this function to give my code the answer. I don't want it to print it to the screen. If we write this as a void function that just prints out the answer, great, it prints out the answer, but that doesn't help me if I want this function to calculate a max value that I'm going to use to do further calculations with. I need just the answer to come back from the function, not for it to be printed. All right, if I want to print out the answer, I can do that in main. If I want to read in some numbers and figure out the max, I'll read them in main and then ask the function to work on those values. The exception to this rule is if a function's job is to print things out, like print as money, great. It can be a void function that just prints stuff out. That is its job. If we have a function that's designed to get an input from the user, maybe by printing out a special prompt, getting the input, maybe it's more complex and it's going to make sure that the input actually looks like the right kind of data. Well, wonderful, we can write that as a function, get balance from user. It returns a double. Its job is to go read from the console and give me back the answer so I can use it in my code. Those are the kinds of functions that should be using the console. But in general, most of our functions that are doing some calculations, those should just communicate with the rest of the code via their parameters and their return and should not be using the console themselves. What this means is oftentimes we have a choice. We could write a function getGrade. It takes in a double representing a percent and it's going to turn it into A, B, C, D, or F, a char, and return that back to us. Or I could write a function called printGrade that takes in a double representing a percent and prints out A, B, C, D, or F. Because it's just printing out the grade letter, it's a void function. It doesn't return anything else to us. Functionally, if this is the entirety of my code, these do the same thing. PrintGrade does the output itself, so there's nothing that has to happen with that function call. GetGrade doesn't print out anything. It gives us back an answer, so we have to print that answer out ourselves or store it in a variable so we can print it. So from these two examples, it almost looks like the blue one, PrintGrade, is cleaner. Well, what if I want to do something else with this character? Right? What if I'm trying to not print it to the console, I'm trying to put it in a database, or generate a web page, or make a whole list of letter grades? Well, this green function focuses on one job, on that job of turning a decimal or double value into a character. It leaves what to do with that character to the rest of the program. And that's a more flexible approach than this function that does two things. It converts from the double into the character and prints it out. Right? The function that does two jobs has made it less flexible because it always has to do those two jobs. So in general, we're going to favor functions that look more like this, that just do one job, do it well, and give us back an answer that then we can build on or use.